Here we have another example. Let s of t be equal to that. Find its derivative. Okay, so let's start with the derivative. Um, so to find the derivative of this function, apply chain rule. So you're going to apply chain rule, which says that dy over dt is equals to dy over du multiplied by du over dt. And here we are assuming that y is equal to 2e to power cos 5t minus 4. Okay. Okay. So then we need, if you're applying chain rule, we need to say, well, let u be equal to this power here. All right. So this will be our u. Okay. So if we let u to be equal to cos 5t, du over dt will be equal to 5 inside, then followed by outside, 5 multiplied by negative sine 5t, okay, which will be equal to negative 5 sine 5t. Okay, now then we have y. Now y will be equal to from the top here, y will be equal to, so yeah, that's what I meant to, yeah. So y will be equal to 2e to power u minus 4, which means dy over du will be equal to 2e to power u. Okay. Now we need to put these results together. So we know that dy over dx is equals to dy over du multiplied by du over dx, which means that we shall end up with 2e to power u multiplied by negative 5 sine 5t, which will be equal to, so that will be negative 10 e to power cos 5t sine 5t. Okay. So this is our first derivative. Okay, so we can carry on to part 2 of this question, which means show that the second derivative will be equal to that. So we need to differentiate. The first derivative. So which means the second derivative. So this is part 2 now. We need to apply product rule. Because you have a product of two functions here. So we can go ahead and say the second derivative will be equal to, so that will be negative 10 e to power cos 5t d over dt of, I hope this space will be enough. Yep, sine 5t, okay, and plus sine 5t d over dt of negative 10 e to power cos 5t. Okay, may just have to create more space on the left. So this means that s, the second derivative, will be equal to, so that will be negative 10. I need to start differentiating here. E to power cos 5t. And here I'll just have inside, outside, so 5 cos 5t, applying chain rule, plus sine 5t. And then inside I'll have, so that will be negative 10 because that's a constant. Apply chain rule, so that will be negative 5. If you differentiate the power of e, negative 5 sine 5t. And then e, so inside, outside, so that will be e to the power of cos 5t. Okay, so we need to put these results together. So on the left, I'll have negative 50 e to power cos 5t, and then it will be cos 5t, plus 50 cos 5 multiplied by 10, negative, negative, positive, and e to the power of cos 5t. But then I have sine 5t and sine 5t, so that will be sine 5t squared. Okay, which means this will be equal to, let's factorize out 50 e to the power of cos 5t. So what we'll end up with is negative cos 5t plus sine 5t squared, which will be equal to, we need to rearrange, so 50 e to power cos 5t into sine 5t squared minus cos 5t. And that is what we have here. Okay, so that's already proved. We can move to part 3, hence verify that S has, now this is a local minimum, so verify that S has a local minimum at t is equals to pi over 5. Now we know that for us to do that, if x equals to c is a minimum point, then the first derivative has to be equal to 0 at that point, and the second derivative has to be greater than 0. So let me just write that statement down here. What I'm saying here is that we have to use the definitions or the facts that we've already learned to be able to verify this point. So if x is equals to, in this case, we have been given x is equal to pi over 5, pi over 5. So x is equal to pi over 5. Then, if this point is, no, actually it's not x, t. If t is equal to pi over 5, if this point is a minimum, then the first derivative at that point, okay, has to be equal to 0. And the second derivative at this point here has to be greater than 0 if it's a minimum point. Okay, if it's a minimum, then these two things have to happen. So basically what you are going to do is we are going to check if this is true for this function and if this is true for this function. Okay, if those both cases are true, then we'll say then this function has a minimum at t is equals to pi over 5. So how do we do it? That's exactly what you're going to do next. So what you're going to do next is to work this out. So we'll go ahead and say, so the value of this function, the value of the slope of this function at pi over 5 will be equal to, we plug that into the first derivative. Okay, do we have the first derivative? Yeah, we have the first derivative here. So we are going to plug that into the first derivative. Let's see what we end up with. We shall end up with negative 10 e to power cos 5 multiplied by pi over 5 multiplied by sine 5 multiplied by pi over 5. And what you're going to end up with here is negative 10 e to power cos pi multiplied by sine pi. Now we know that sine pi is 0, so this will just be equal to 0. Okay, which means that we have verified that the value of hence the value of the slope at pi over 5 is equals to 0. So that's one of the things. Okay, so we have already done that. Now we need to do the second one, which means we need to plug in pi over 5 into the second derivative. So we'll go ahead. What is our second derivative? So okay, anyway, so we need to plug pi over 5 into the second derivative. Now if we plug that into the second derivative, we'll end up with 50 e to power cos 5 multiplied by pi over 5. Okay, this is the second derivative here. So into bracket 5 multiplied by pi over 5 minus cos 5 multiplied by pi over 5. Okay, so we need to work this out. By the way, let's simplify this. So that will be 50 e to power cos pi. We know that cos pi is negative 1. Sine pi squared minus cos pi. Okay. Now we know that cos pi is minus 1. So and sine pi is 0. So this will be equal to 50 e to power negative 1 into bracket 0 minus minus 1. So that will just be 50 over e. Okay. So we can say hence the value of the second derivative is greater than 0, which confirms our second condition. So we can say that, well, at t is equals to pi over 5, it will be a minimum point. So we can write our conclusion, and our conclusion will be that since the value of the slope at pi over 5 is equals to 0, and the value of the second derivative at pi over 5 is greater than 0, then by second derivative test, S has a minimum at t is equals to pi over 5.